Hello everybody, and welcome to the webinar of High Availability Options for SQL Server. Thank you very much for joining. This is your host, Tim Christie, and you may have had a chance to actually read through my bio when you signed up for the webinar. If you didn't, I would like to take this time to actually introduce myself. I've been working in technology for over 20 years, and more specifically in the IT technical training industry for almost 3 years now. I specialize in helping CTOs, IT directors and managers address the IT skills training needs and help them get the most out of their IT training budgets. Well, I could go on about myself, but I want to quickly move on to the real star of the show, my esteemed colleague and presenter of this webinar, Jeff Rathjen. Now, I'm sure many of you are here actually because of Jeff. You've either had the pleasure of training directly with him or you read about him. Jeff is one of the pioneers in this industry and has put on a lot of work into this webinar. So Jeff, if you could, please tell us why you chose this topic.
Well, that's a great question. I guess because it fascinates me. So I think that high availability is a fascinating topic in the sense of it's something everybody wants, but it's not something everybody ends up getting. And there's so much confusion about high availability and what it even means, let alone how to get there, that it's just one of those things that's hard to deal with. And I think I've been teaching about high availability for, I don't know how long, longer than I'd like to admit. And it's just one of my favorite topics.
Oh, very good. Well, for those who are just joining us right now, welcome to the webinar, High Availability Options for SQL Server. We are with one of the first MCSEs in the world, and we're just about to start our discussion. So let's get to it.
All righty. Okay, so Tim, did you want me to share video or not?
That's fine with it. I'm fine. I'm fine either way.
All right, you'll have to unblock it. Well, it doesn't matter.
Okay.
All right. Well, thanks everyone. Thanks for coming. It's a pleasure to be here. It's an exciting time to be involved with SQL Server. An exciting time to be with SQL Server high availability options with things that have happened even, almost daily, but also just in the last few years, a lot of stuff has been happening. As Tim mentioned, I've been around for a long time, which really only proves that I'm old, is all that it really proves. But I have been working with SQL Server since it became a product. So my first introduction to SQL Server was back on OS 2, running SQL Server 1.0 back in the late 80s. Someone walked into the office where I was working and there was a box and they said, it looks like it might be a database, so it's probably yours, because we were working with databases. I was working with Fox Pro and all those DB2 and all those kinds of things. And I took a look at it and I thought, SQL Server, I wonder what that's all about. And I'll be honest, there are times I still call it SQL Server, but I've learned better. And I have fallen in love with SQL Server. It is my favorite thing in the technical world. It's my passion. You'll find me on a weekend playing with SQL Server, which is embarrassing to admit. I ought to have more of a life, but I just don't. So with that introduction, let's get started and talk about SQL Server. But before I do that, let me give you a couple of ways to get in touch with me. I put my name down here at the bottom, but I also put two really important pieces of information. My email, and if you want to ask me a question, you certainly can and send me an email. Here's the problem though. I'm teaching all day long. And so my ability to respond to you is not, even with the best will in the world, is not very fast. I don't get back to people very often. In fact, I hear that once in a while. You really need to respond quicker, and it's true, I do. But I'm not going to interrupt my class time to answer email questions. If you have a question that you want answered, really the best way on earth is to go to our Expert Connect website. Expert Connect gives you the ability to ask questions. And it's not just me, but all of the SQL Server people at Quick Start will be notified that you have a question. And other people who are maybe not Quick Start employees, but equally interested in SQL Server, they have the option of also being notified. And so you don't have to wait for me to answer your question. You can go there, ask it, and any one of a number of people will be able to answer your questions. You know, I got to be honest with you, because honesty is where I'm at with all this stuff. We're just getting this started. We've been at this, I don't know how long exactly, but a few months. And so there's little buggy things in there that we're still working out. But like with any new product, you know what it's like to work with little bugs. So bear with us as we get all those things taken care of and worked out. But this is becoming a tremendous resource, because it's not only that, it's a curated library of white papers, resources, video clips, things like that. Video clips, not that we have necessarily made, some are, but mostly we go out and scour YouTube just like you would, except that we do it for you. So all of the stupid ones that didn't answer your question or went way too long or whatever, we can filter those out. And when you come into our curated library, they're all a bunch of videos that we give a thumbs up to. So with that said, let's get into the topic. So I really want to talk to you about the different options for high availability, but before we do, we got to define what we mean by high availability, because that's some of those topics that it sounds like everybody understands, but quite frankly, there's a lot of confusion about what high availability is. Then we're going to take a quick look at the high availability options that have been offered kind of since the beginning. And we're going to do it not just for a History Channel kind of tour. All of them are still viable and still available. And whether they fit your needs or not, there's still certain niche places where those older high availability options can work. Then we're going to walk through the modern ones, of course, and then we're going to break them down and talk about the pros and cons of each option. Why would I want this one versus that one? And there isn't any, this one will take care of all your needs type of thing. So different needs will have different options, and we'll talk about those. And then finally, we're going to wrap up and talk about how do you choose? How do you make a decision about which option? Now, at the end of that time, we're going to have a question and answer period. But if you have questions while we're going, feel free to type them in the chat window. And I will get, when we come to suitable breakpoints, we can address those questions. So you don't need to save them till the end, but you certainly can if you'd like to. All right. So what do we mean by high availability? I know that sounds like an easy question, but I was hired by Intel one time to solve an availability solution for them, a problem that they had. And the problem was they had an application that was doing $2.8 billion per month, and it had about a 60% availability. And so they were measuring downtime in the tens of thousands of dollars per second, and they were bleeding all over the place. So they asked me to come in and help figure out what to do to make this an available solution. Almost immediately, the question came up, well, what do you want for availability? What do you want it to be? And you know what the answer is, 100%. Well, my reply was, I can't do that for you. You'll have to fire me and go hire somebody else, because I don't think anybody can guarantee you 100%. And then, of course, we start that age-old dickering. Well, what about 99.999% availability, or 5 nines? What about this? What about that? So what I finally came down to after a few days of going back and forth like this is I said, all right, you need to define to me what your measurement is. I can't do that for you. You need to tell me what your availability means, or what that number is. And then you have to tell me what availability actually is. So in other words, if I have a 1 hour maintenance window for this application on Friday nights, does that count against my availability? And I know that everybody wants to be quickly answering, well, no, of course it doesn't. It doesn't really matter as long as we all agree. If I am going to count a 1 hour maintenance every Friday against my availability, I can't get anywhere close to 5 nines, 99.999%, because that's a few minutes down every year. So we have to define what we mean by it. And then there are other questions that you need to define. For instance, if the physical server is running, SQL Server is running, the application is running and the data is available, but the router is down, or sorry, the firewall is down to the internet, is it available? Once again, I don't have an answer for you. And I don't think it really matters what the answer is, as long as we define it and capture that. Once we really get a real strict definition of availability, that it might look something like this. At a certain number of minutes or hours per day, per year, whatever you want to measure it as, the application will be able to respond to a request within X number of seconds, and it will return correct data as measured by this standard. Great. Now, how do you go about measuring that? Because I've seen so many SLAs that demand this high availability, but nobody ever measures it. And so you could demand anything you wanted from me. As long as you don't hold me to it, I'll agree to anything. You need to find a way to measure availability. Are there third-party agents that you can buy and install around the world? Where do you want to measure availability from? Is it only within your own? Maybe it's only an internal application and you don't care about availability outside. But you've got to define a way to measure it that is repeatable and regular. Excuse me. And then, of course, document that. I know everybody gets sick of hearing me say document it, but that's the only way to do it. Let me tell you a quick story. When I worked for that, for a company, Intel, I think I said the name already, so I might as well go ahead. I wasn't supposed to, but I'll go ahead and say it. When I worked for them, we were measuring availability for that application from, I believe it was 9 different points around the globe. And one of those points was Taiwan. And at some point, the internet cable got torn up, got destroyed. And so that particular agent wasn't able to access my application. And so I reported that to my boss. I said, no worry, it's still available, but it's just this one agent isn't measuring. Well, later that quarter, we went to look at my quarterly bonus and it didn't exist. And the reason was I failed to meet the availability requirements. And what it boiled down to was that agent wouldn't measure. And I said, hey, that's not my fault. Didn't matter. I hadn't done a good job of documenting the SLA. And so guess what? I didn't get that quarter. And guess how fun it is to go home and tell your wife that you're not going to get to on vacation this year because I didn't get that quarterly bonus. It's not fun. So protect yourself. Make sure that SLAs are documented. And then the most important question you need to ask for any availability solution is, what does it protect? And what doesn't it protect? Different solutions protect different things. Make sure that the solution you decide on protects the things that you really want to protect and not something else. I'll give you some great examples of that as we go. Okay, so I'm going to make a hard dividing line in SQL Server 2005, everything prior to that and everything after that. The reason is the world changed in 2005 for SQL Server. Everything went different. So we're going to look at everything prior. And by the way, all of those solutions that were available to prior to 2005 are still available, and in some cases or another may still be a great option. But I don't want to focus a lot on the past. So we're going to talk through these a little bit quickly. but they were log shipping. And I was trying to find out the other day because I really couldn't remember whether log shipping was available before replication or vice versa. And I don't really remember, but so I'll just say log shipping came first and replication came second, and I may be wrong on that. But log shipping was the first one that I kind of think of anyway. And then replication, and then failover clustering. So log shipping works like this. We have two computers. Do you like the way I chose these computers with floppy disks in them? That's how old this was. They actually used floppy disks back then. Right? So I purposely found a picture of a server with floppy disks in it. Now, you would take a backup of your database, and this was a one-time event. You would back up your database, and then you would move that copy over that file, that backup file, over to the other physical server and restore it. So that at this point in time, my two computers for at least this one database were exactly in sync. Then you would schedule a transaction log backup. Now, if I talk about some of these things like transaction log backup, and those aren't familiar to you, you don't know what I mean by that, please ask a question. I'll be glad to give a quick idea, but I'm kind of assuming since you're here, these types of things already make sense to you. So we would create a schedule, maybe every hour, every half hour, twice a day, whatever you wanted to. You'd create the schedule, and at those times, the transaction log would be backed up and would be copied, that file would be copied across the network to the other server, which would then restore the transaction log backup. So we always had a standby machine. However, this second server was always in restoring mode. In other words, it couldn't respond to any user requests, but I had a backup of my data. I had my actual literal backup, but I also had a hot standby so that all I needed to do if my first machine died was to do a quick restore. So my end user here would sit down and would connect to the first machine and do his or her queries. If something went wrong with that first machine, the process looked like this. First thing we had to do was to bring my secondary machine, the one that had been receiving the log shipping devices, and restore it completely. So it's no longer in restoring mode, but it's in multi-user mode. And then we would have to go over to my end user and say, oh, we had a problem. Why don't you disconnect that query, that session, and reconnect to this other server with a different name? That was perfectly fine if you had 10 users in the universe. When you started having very many users, that became very problematic. Log shipping has evolved since then. There are certainly better things going on in there, but that's the way it started off. And quite frankly, it was kind of a worthless solution. It has some places that it still makes sense today. And that has to do with the timed nature of the restores. There are environments where I work where the ability to constantly have these two computers communicate with each other is not there. Some of the environments I work in, they don't allow connections except for at timed periods, once a night, maybe 2 o'clock every morning or something like that. And so the ability to time this is great. But here's the major drawback to this with log shipping is my second copy of the data is always out of date. How much out of date it is depends on how often you do those transaction log backups and restores. But it will always, 100% of the time, be out of date. So at any given time, if my first server dies, I will have lost data, period, end of story, no getting away from that. I can reduce the amount of loss, but I can't eliminate it. So log shipping was historically if not the first, one of the first solutions. It was not a great solution, but at the time, it was a lot better than what we had. Then came along replication. And just like log shipping, replication has evolved over the years. Initially, quite frankly, it was a horrid solution. It didn't work. It developed a really horrid reputation. And it was always just one way. One server would replicate its data to the others. So I couldn't update my data on the other servers. That was in the past. It's no longer true. We now have several different forms or installation methods of replication. But the way it stands today is each one of these computers can accept read requests and write requests, and they immediately replicate that data to either one other partner, or in the case where we'll be talking about, they would replicate that data to all other partners. There are built-in mechanisms for dealing with what happens if I change this data in this place and at that place at the same time. We're not going to get into all those details, but those are available and they do a good job. Replication today is actually a very excellent process. But it doesn't do me any good if that's where I stop. I can have all of these servers all completely up to date, never missing a bit of data, but then what does my user do? Which one of these computers should my end user connect to? So we introduce something else, and we call it, what we introduce is a network load balancer. Now, Windows has network load balancing capabilities built into it. Please, if you value your sanity, don't use it. It's not that it's really so bad all by itself, but it's a software solution, and it's never going to keep up with any kind of demand. Go buy a hardware appliance. You can get them from all sorts of companies, Cisco, Barracuda. I'm thinking, my mind's drawing a blank, but there are tons of devices you can buy network load balancer devices from. I used F5 here in the example because I really like F5s. And I have to be honest with you and tell you why I really like them. They're a great product, but they have more blinky lights on their appliances than any other device I've ever seen. And blinky lights just attract me like honey does bees or whatever it does. I love blinky lights. And then they also once gave me a sleeve of golf balls with F5 written on each one of them. I fell in love with them. I thought they were great. So I love F5s. But all joking aside, they are a great appliance, but it doesn't matter which one you use, any network load balance appliance, but make sure you buy a hardware appliance and not use Windows. How that works then, what happens is I have a user. The user wants to connect to an instance of SQL Server to do some querying or some updating or whatever. She will contact DNS and say, what is the IP address of this server? DNS will lie to her and will tell her the IP address is really the IP address of the network load balancer. That request comes into the NLB. The NLB, the network load balancer, then finds the most available server to answer that request. Since the data is being replicated on all of these servers, it just simply chooses which one has the least current load. Different load balancers, and this was how they distinguish from each other, some of them do just a eeny, meeny, miny, mo, round robin kind of thing. That's a terrible way to go. Others say, well, I sent one request to this computer and one request to this computer. I haven't sent a request to this third computer, so I'll send it next. That's a little different from round robin, but it's not great. Then there are solutions, some of the hardware solutions. We'll take a look at what servers have the fewest number of requests stacked up. That's a big advance. But really the best network load balancers look at that plus the current tax on their hardware. So they may not have a lot of requests stacked up, but the CPU is pegged at 90% and the disk I/O is through the roof. So even though there aren't that many requests, we're going to skip you for now and go somewhere else. Every user that comes in gets redirected to one of the computers, one of the servers running in the background. And the load balancer is configured with each of these computers. The beauty to this solution is its scalability. If I am running a program, some kind of advanced thing, and suddenly I'm looking at my website and it's just trashed and the SQL Server is barely keeping up, all I have to do is go pick up a new computer somewhere, not new, like go buy it, but go grab one sitting on a desk somewhere, configure it with SQL Server, replicate the data to it, and then tell F5 that it exists. And suddenly now you've just scaled from 5 computers to 6 or whatever. And then later when that marketing campaign or whatever goes away, you can scale it back down. It's also nice because in some solutions, each of these computers have to be exactly the same. And from the looks of how I drew this, well, I didn't draw it. Okay, I stole the clip art from somewhere. But from the looks of the clip art I stole, it looks like they're all the same, but that's not necessarily true. I could have really powerful machines next to dogs, and it's fine because any one user is going to be communicating with one server at a time. So when this yellow session gets started, the network load balancer makes sure that it only talks to that computer number 2 until the session ends. The next time our user comes in, she might be connected to a different computer, but whatever computer she's connected to, that session is static in the sense of it doesn't change unless something horrible goes wrong. But let's say our blue session here is communicating with that last computer and it dies, catches on fire, dies, horrible, painful death, whatever it is. In that case, the network load balancer sees requests being unanswered and will suddenly redirect those requests for the blue user to a different backend server. So replication is a really fascinating and great way to go. And it's also one of the cheaper solutions and one of the more scalable. I actually, even though this is one of the oldest solutions available in SQL Server, it's one of my favorites. Okay, let's change gears and let's talk about Windows failover clustering. Windows failover clustering has been around since, I don't know, the mid-90s, something like that, somewhere around there. And it's really not a SQL Server thing, it's a Windows thing. And it's an ability that Windows Server has to have 2 nodes, and if something goes wrong with one, fail over to the other. SQL Server just rides on top of this. Now, SQL Server was the very first application Microsoft ever created that was cluster aware, and I think it may be one of the very first applications, at least that still exists today, that ever was cluster aware. But here's how it works. I have 2 computers. They must be exactly the same. I mean, we have to get down to like the CPU. Both the family and the model have to be the same, and the stepping of that CPU should be the same. The microcode revisions really ought to be the same. Doesn't have to be, but the family and the model certainly does. The number of cores, the amount of memory, the type of network card, the number of network cards, number of disks, all that stuff has to be exactly the same. In fact, so much so that Microsoft now publishes what's called an HCL, a hardware compatibility list. And that hardware compatibility list has always existed for Microsoft operating systems. And it's always been one of those things, oh yeah, I've heard of that, but nobody pays attention to it. With Windows failover clustering, if you buy hardware and try to install failover clustering on it, and it's not on that HCL list, the installation process just simply says, nope, I won't do it. So it is a very particular solution, and that hardware, as you might guess, ain't cheap. They know they're on the HCL, they can charge what they want for it. So it's a fairly expensive solution. So I start off with two computers, and they are exactly the same. Since they are exactly the same, I don't care which one is active and which one is passive, but one of them has to be active and one of them has to be passive. Now let me explain that I'm showing you Windows failover clustering at its simplest. It gets way more complex than this. We can have active, 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 passive, active. We can have up to, I think the latest number is like 16 nodes. That can get way, way more complex than this, but that doesn't help us understand it as a SQL availability option. So I'm not going to go get into all that. So at its simplest, I start off with two physical computers, and one of them I choose to be active and one of them I choose to be passive. I've named them Node A and Node B because in the parlance we talk about nodes. So I call them Node A and Node B. I'm not very good at coming up with creative names for things. So we chose Node A to be active and Node B to be passive. Since they're both exactly the same, it really would make no difference. Unless those two computers are in separate geographical areas. Ideally, with a failover cluster, they'd be sitting in the same rack right next to each other. But I don't live in an ideal world, and I know you don't either. So we often have them maybe racks away on the other side of the data center, maybe in different data centers across town, and maybe we participate in what we call geo clustering. You know, Node A might be in Toronto and Node B might be in Shanghai. And that's fine. There are limitations, I should say, with that. There are problems we run into, but it's perfectly fine to do geo clustering. It wasn't always, but it is now. So we chose Node A to be active and Node B to be passive. If this was geo clustered, if these were in different locations, we would choose the active node to be the one that was closest to the most number of users or consumers of the data. But in this case, if they're going to sit in the rack right next to each other, it makes no difference which one is which. Those two computers share an external hard drive. That external hard drive could be an external iSCSI disk. It's unlikely anymore. In the early days, that's what we used. But nowadays, almost exclusively, that external SCSI disk is going to be a SAN, a storage area network. That SAN, or that external disk, whatever it is, will contain your data files and your log files. Now, if you've ever taken a class from me, your ears are perking up because you're saying, wait, the data files and the log files on the same disk? Jeff always preaches against how bad that is. And yeah, I do. And yes, it is that bad. And that's one of the reasons I'm not a big fan of failover clustering. But let me hold off on my opinions till we get it thoroughly understood. But my data files represented by the MDF and the log files represented by the LDF file all exist on the same physical disk. I know what a lot of people are thinking because I've heard it 100 times before. Yeah, but my SAN is going to protect those files. Okay, if you believe that, if you really, really believe that, I have real estate in Northern California I'd love to have you take a look at. If you really believe the SAN can be trusted to always protect your data files, then there are a lot of places I can take you. But even more importantly, so what? My SAN may be able, let's pretend it can. It can perfectly take care of my files. That doesn't really help me because I just installed a very expensive failover clustering situation and I didn't protect my data. The SAN does, but my solution doesn't. We'll get into that. I'm getting ahead of myself. So I have these two computers, one's active and one is passive. On the active node, SQL Server is installed and the services are running. On the other node, the passive node, SQL Server is installed and the services are stopped. In both cases, they are set to manual, not automatic, but but on the active, the services are started and running. On the passive, they're stopped. Now, each of those computers has their own network cable, their own network access, their own IP address, all that kind of stuff. And typically, the two computers communicate to each other via your regular network, which works very well if they're on the same switch. They're in the same VLAN, for instance. But if they're not, like if they're geo-clustered and for some reason they can't be on the same VLAN, we can use what's called a heartbeat network. This is a dedicated network to nothing but these two computers or however many nodes you have. And it's a heartbeat network, and it's where the two computers or nodes constantly tell each other, I'm alive. So 6 times every second, node A says to node B, I'm alive. 6 times every second, node B says to node A, I'm alive. And it starts to feel like, remember those old annoying Verizon commercials where the guy was walking around going, can you hear me now? Can you hear me now? You know, it's like that. So that heartbeat network can be a single point of failure. It's really not that big of a deal though, because I still have my regular network. And if I'm really worried about it, I could install 2 heartbeat networks. I think that's kind of overkill, but you know, it's certainly a possibility. And for the price of 2 network cards and 1 cable, you're what, $150 into this now, and you've got you've eliminated a single point of failure, a SPOF, and so that's a good thing. Normally, I don't see heartbeat networks installed though. All right, last thing that we do, not last thing chronologically, but one thing, this all happens at the same time, is we have what's called a resource group. That resource group has its physical existence on that shared drive. It's physically a file there, but it is loaded into memory and running on the active node. It contains lots of things, but for our purposes, the only 2 important ones are the name of the instance. Notice I didn't say the name of the computer, the name of the SQL Server instance, and the IP address. Once again, just like with replication, if you were to go look up in DNS, it would say that this instance named, you know, my production CRM or whatever it is, its IP address is 10.10.0.96. In reality, there is no physical device anywhere in your network with that IP address. It's a lie. It's a virtual IP address, if you will. But when my end users go to connect to it, they contact DNS, and DNS gives them that IP address. And so it is interpreted by the active node, and all the requests go to it. It writes its data to the shared drive. It reads from the shared drive. Everything's running fine until that day something goes wrong. Whatever that something is, it could be anything. It could be a hardware failure. It could be an instance failure, a corrupted binary file. It could be any number of things. It could be that the network card took a dump. You know, who knows what it is. Whatever it was, node B stops hearing from node A. And it lets a second go by and says, wow, that's 6 times I haven't heard from it. Lets another second go by. And at the end of the 3rd second, it says, that's it. Node A must be gone. Because if it was alive, I would have heard from it a bunch of times. At that point, we end up with why we call this failover clustering. That resource group fails over and starts running on node B, which has been the passive node. At that same moment, the services on the first machine are either shut down or they weren't able to be shut down at all because the server may be completely gone. But if they are running, they're turned off, they're stopped. And the services on what has been the passive node, node B here, are started. This process is what accounts for almost all of the delay when a failover occurs. SQL Server services are not very slow. They start up pretty quickly, but whatever time it takes your services to start accounts for almost all of the time it takes for the failover to occur. Microsoft published, and this is amazing to me, published that failover for, they weren't talking specifically SQL Server, but things in general, would take between 2 and 12 minutes. That's ridiculous number. It won't take you 12 minutes. It won't take you 2 minutes. First time I saw that, I had to check and say, wait, is that 2 or 12 seconds? Because, 10, 15 seconds is what I would expect to failover to be. So I suppose, like as an example, Microsoft Exchange, the services take about 1.5 years to start up. They're just terribly slow because there are so many of them. And so they can take quite a bit longer, but SQL Server is pretty quick. When it fails over fairly quick. The services start up quick. The resource group fails over, and now those clients which were connecting to 10.10.0.96, they're still connecting to the same thing. It's just that we moved that over to another physical device. Does that make sense? Any questions about that? Okay, let's talk about, just quickly, we'll go over this in detail later, but while we've got this picture up here, let's just talk a little bit about the weaknesses of a failover cluster. Number one, we have a huge single point of failure right here in the disk. Yes, I know, it's a SAN, it will never fail. Yeah, right. SAN is taking care of it, great, but my SAN was already taking care of it, and my buying an expensive failover cluster solution didn't add anything to that. It didn't add anything to protecting my data. So once again, the question of what am I protecting here? In a failover cluster instance, what I'm protecting is the availability not of my data, and I'm certainly not protecting the data itself. I'm protecting the availability of the instance. And that's all I'm protecting. Now, I don't want you to get me wrong. I don't think clustering is a horrible solution. I just think it's a horrible solution for SQL Server. Okay, so at this point, the services have started, and node B goes from having been passive to being active. Now it's my active node. At some point, node A, we're going to fix the problem, presumably. And people ask me quite often, well, at that point, should I fail back to node A? And my answer is why? Why would you? The two pieces of hardware are the same, the data's the same, everything's the same. There's no reason to fail back to node A, but you certainly can. All right, so that brings us up to 2005. All the solutions that we just talked about were in 2005. Now, I want to be clear, all of those solutions have been improved since then. There's been significant work since they originally came out, and they're still improving them. But that's the way that we stood at the high water, or not the high water mark, that's not it, the dividing line, let's say, between the old and the new, 2005. Now what I'd like to do is talk about modern high availability. And modern is relative. I remember talking something that's at least at minimum 10 years old, which in technology is pretty much prehistoric. But since 2008 came around, we've started picking up some really significant high availability options that give us a whole lot better choice.
And Jeff, before we move on, we did have a couple questions come in.
Okay, go ahead.
One was earlier about load balancing. And just to kind of summarize the question is, why regarding the Windows load balancing, is there any specific issue around using the Windows load balancing?
Basically, no. Well, yes and no. First of all, Windows load balancing tends to be more of a round robin thing. So in other words, it looks at, I gave it to server 1, then to server 2, then server 3, server 4, server 5. Now I'm back to server 1. That's a little bit oversimplified. It's not quite like that, but it is basically a round robin technology, so that even if server 1 is really busy and server 2 is not at all, it's still going to drop something off on server 1. That's not the end of the world, but it's not good. The biggest problem with Windows network load balancing is it's a software implementation. And quite frankly, a software implementation is never going to keep up. If you have enough activity that you're interested in these kinds of high availability solutions, I have to assume that you have a lot of activity going on. And a software solution is very unlikely to keep up. Oh, I know there might be exceptions. There might be some very important data that doesn't get a lot of activity. Okay, so there are exceptions. I'm trying to hit more towards the general here. So
Okay.
that's why I'd be a big fan of Windows.
Thank you for that. And actually, Imran had a second question about SAN. If they don't use SAN, what will happen?
In a failover cluster.
I'm guessing.
So the only two real, okay, there are three options. There's SAN and there's NAS, network attached storage, which isn't really an option because SAN is very fast, almost as fast as if that disk was physically sitting in the computer. Not quite, but almost. A NAS is at kind of the speed of dirt. It's very, very slow. So while you could use it, you wouldn't ever use that. So the only two realistic options are SAN and then an external iSCSI disk. An external iSCSI disk works just fine, but it's kind of old-fashioned. Most people today, there are so many advantages of SAN over just this physical disk sitting there in your rack, so those are the only two realistic options, SAN and an iSCSI disk. Other than that, either one would work, really does work just fine, but SAN has a lot of advantages in and of itself. It's not load balanced, but it's balanced. It's trying to think of the word to say. It basically takes care of backups and those kinds of things a lot on its own.
Very good. And one question came in from John Kim on YouTube regarding replication today, implying SQL Server 2016 or replication irregardless of version.
I would say replication of any version, let's say 2008 or newer. SQL 2000 had some reasonably significant problems with replication, at least when I used it, and I never got it fixed. 2005 fixed a lot of those problems, but there were still some difficulties, especially when it came to the way it handled conflicting data rights. So if I write to server A and you write to server B, the way it handled replication in that time frame, that was, what would that be? Windows Server 2003, I guess, is what would have been the current Windows Server at the time. It didn't handle those kinds of conflicts very well because of the operating system. The operating system didn't have very advanced ways. And so what it basically had was a whoever started last loses kind of an attitude. And so it wasn't a great solution. They've improved that quite a bit. And in SQL 2008, replication really kind of came into its own. And so I'd say anything newer than that is a good solution. 2005 is a pretty good solution. SQL 2000, I might not be willing to choose that one. Okay.
Thank you.
Sure. That it? Or are there others?
That was it for now.
All right, great. So let's move on then and talk about what we're at today. What are our options today? It's a much more interesting topic. So we really are boiling down to, as I mentioned a couple of times already, all those solutions still exist. But now we have mirroring, which was introduced in 2008, and AlwaysOn technologies, which were introduced in SQL 2012. They're very kind of similar. So I'm going to spend a little more time talking about mirroring. And then when we talk about AlwaysOn, I'll say, well, it's just like mirroring in this area, kind of a thing. Mirroring, notice my servers are continually getting a little bit more modern each time. In mirroring, I have a primary machine and I have a mirror machine. These must be two separate servers. They don't need to necessarily be two different computers, but they probably are. Now, if that confused you, let me just say that in the world of SQL, we use the term server differently than most people do. To us, a server is an installation of SQL Server, and SQL Server may be installed multiple times on the same computer. But to us, a server is an installation or an instance. It's the same thing to us. So you can install mirroring between two instances on the same computer, but I can't think in the world for the life of me why you would do that. It makes no sense. So really, we're talking about two separate computers if we're being realistic here. And I have one of them I'm going to call my primary and one I'm going to call my mirror. The beauty of this solution is those two machines do not have to be the exact same thing. And in fact, they don't have to be anything special. So you don't have to spend lots and lots of money on this hardware. You certainly can, but it's not a requirement of the solution. My primary machine and my mirror machine have to start off with the same database. So we have to do something like back it up from one to the primary, restore it on the mirror, or something, some process like that. There are some automated processes for that, but one way or the other, they need to start with the same database. Now, in addition to these two, we have another computer that we call the witness. The witness does not have to be anything special at all. In fact, I usually recommend it be some other SQL server running, doing something unrelated to these two, and hopefully not in the same rack as each other. And the witness server kind of takes the place of the heartbeat network in a cluster. It's the one that is listening to the two computers, and while they don't talk to each other directly, they're both in communication with the witness, and the witness is making sure that it knows that both computers are up and running, and the SQL server is responding. Okay, I have a severe love of bad jokes. I love hearing bad jokes and I love telling bad jokes. And the worst joke of all, any joke in the world, is a pun. That makes it my favorite. So, are you ready for a pun? We could take that witness server and put it on a failover cluster of its own. If we did that, you know what we would call that? We'd call that a witness protection program. Okay, enough bad jokes. So we've got this computer running the witness process, and all it's really doing is listening to the primary machine and the mirror machine to make sure they're alive. Now, there are two ways to configure mirroring. The first one I want to talk about is what we call partner safety, or technically it's called transactional safety. What I mean by that is the stated goal of mirroring when they came out with it was that the mirror machine would not be out of date. Or they often talk about this as having 100% transactional consistency. In other words, the mirror machine must always have all the same data as the primary. There can never be a time when the mirror is out of date. To accomplish that, we do partner safety or transactional safety. And it looks like this. My user up here in the corner creates a transaction, doesn't update or whatever, it doesn't matter. Normally, that transaction would be sent to the primary server's transaction log and written there. That's not what happens in this case. That transaction goes to my primary server, but my primary server suspends that transaction, does not write it to the log, but instead sends it to the transaction log of the mirror machine. The mirror machine writes it to its transaction log and replies with a partner message saying, I've got this, I'm done. And now the original, the primary, can write the transaction to its transaction log. So at any one point in time, the mirror machine is as up to date as the primary. In fact, it's a little bit more up to date by, we're talking milliseconds here, maybe nanoseconds even, but it's basically, the whole point is it's at least as up to date. So if something happens to that primary, I do not lose any data whatsoever. At least, well, let me rephrase that. I don't lose any data that was on the primary. There will be transactions that are, so if the primary crashes and dies, there will be transactions that were in progress or in flight. I might lose those, but in terms of committed transactions, I don't lose anything at all. Here's the big problem with partner safety. If these two computers are sitting right next to each other, we're in great shape. But if they are spanning geographically different areas, that delay can start to add up. And it clogs up all sorts of things, and it causes locking issues and everything. So if the amount of time between that it takes for that transaction to complete the partner safety route over to the mirror and then back to the primary starts to cause a problem, then we can go into no safety mode. This one is not transactionally consistent, and the mirror will be out of date. How much out of date is nothing like log shipping. We're still talking, I don't know, might be as much as a second, but it just depends on the spread, the geographic spread and the latency. Now I should take for a second and tell you that Microsoft uses the word latency incorrectly. Here's what latency really means. It's not a subjective thing, it's an objective thing. It's measured and it's defined in latency tables. And it is the amount of time that it takes a packet to go from point A to point B. And it's measurable, and it is changed by distance. It's changed by the media, what kind of media we're running on, and it's changed by intervening devices, routers, gateways, things like that. But it is not impacted by bandwidth. It's not impacted by traffic. So latency technically on an OC8 connection and latency on a dial-up DSL modem, if they were on the same physical medium, would be the same. Microsoft uses the term latency, however, to reflect the amount of time that it does take data to get from point A to B. And so if I'm working on a narrow bandwidth and I've got a lot of traffic going on, in Microsoft's world, latency is increased. There is more latency. I only bring this up because it used to just throw me. I could never understand most of what I was reading about from Microsoft because I couldn't understand how they were saying that the latency would increase. I finally realized that what they're saying is not really latency, but delay is what they're talking about. Okay, but to use their terminology, the latency between a primary and a mirror in a transactionally consistent environment might become a problem. So we can institute mirroring with no safety. How that works is kind of similar, but my end user, once again, writes their transaction. It's written to the transaction log over here. It's written. And then a message is sent to the mirror saying, here is that transaction. So at any given point in time, my mirror is slightly out of date. How much? And we're not talking earth-shattering here, but it's not 100% transactionally consistent. Now, here's one of the problems with mirroring is, because that mirror is constantly restoring those transactions, it is not available for use. It is a machine sitting there that you're spending money on that is giving you absolutely nothing but protection. Protection's nice to have, but it is an expensive way to go. I've basically taken that process and made it unavailable. Okay, now if something goes wrong with the primary, I thought I had animations in here for this, but I don't, so I'll just have to walk you through it. The witness stops hearing from the primary and says, uh-oh, something's wrong. And it contacts the mirror and says to the mirror, hey, you're on. Something's gone wrong with the mirror, and you will have to take over. So the mirror stops all of its mirroring activity. It brings its database into online mode, and then the witness server tells my client up here to start using this machine. How does it do that? Well, I'm glad you asked. I'm going to show you a website here, one of my favorite websites in the world, which just tells you how stinking nerdy I am. It's called connectionstrings.com. And it deals with connection strings, obviously. Lots and lots and lots of connection strings. If I look at SQL Server on this website and scroll down, clearly there are a lot of connection strings here. Just the list, I've never counted them. There must be hundreds on here. But look at here is a database mirroring connection string. And it shows you the driver, the server, and as you would expect, the initial database or initial catalog that is a trusted connection. But what's unique about this is this middle part right here. The failover partner equals, and that is an IP address, or it could be a name, but usually we use an IP address. So when my witness detects that the primary is down, it simply responds back to my client saying, start using your failover partner IP address, which is this. If that connection is not created with the right kind of connection string, witness server will work with it to get it in there, but it's going to be more of a delay. Because witness server has to go, oddly enough, it doesn't know what the IP address of the mirror machine is. I know that sounds stupid, but it doesn't know. It has to go contact DNS, find out, and then reply as kind of a transaction to the original poster. Hey, here's the IP address you ought to be using. So mirroring is, or can be, 100% up to date, 100% transactionally consistent, or it can run in a manner that is not quite, but is still really pretty good. Now we come to AlwaysOn. In SQL 2012, they introduced this new earth-shattering, life is going to be good. We're introducing Nirvana, and we've solved all world peace problems, and we've fed all the hungry in the world solution called AlwaysOn. Didn't quite live up to its name, but it's pretty stinking cool still. AlwaysOn is divided into two halves. There is AlwaysOn failover clustering and AlwaysOn availability groups. AlwaysOn failover clustering. Those of you of a certain age will recognize this album cover. And if you know that album cover, you probably know where I'm going. One of the most iconic rock songs of all times comes from this album, and it's called "You Won't Get Fooled, We Won't Get Fooled Again." It's The Who. It's kind of a disgusting album cover. The album's called Who's Next. It's a great album, but the cover just, the more you look at that, you go, ew. But anyway, in that song, in that iconic rock song, there's a great line. It says, "Meet the new boss, same as the old boss." Well, that's exactly what we've got with always-on failover clustering. Always-on failover clustering is nothing more than failover clustering. Absolutely no difference, except it has, 6 more letters? 8 more letters, sorry, that's much better. There is nothing different between always-on failover clustering and Windows failover clustering. Now, to be perfectly fair, Windows failover clustering has improved. There have been significant improvements to Windows failover clustering, but there is no difference whatsoever in the way SQL Server works with it. It's the same old thing. So I wasn't very excited about failover clustering before. Calling it always-on failover clustering didn't help me a bit. That brings us to the flagship. Always-on availability groups. And this is where I really want to spend most of my time. Always-on availability groups are the new things. They started in 2012. They were improved in 2014, improved again in 2016. And what I am starting to hear now referred to as SQL 2019. There's nothing official about that, but that's the kind of the hubbub I'm hearing, SQL 2019. There are apparently going to be radically improved options in here. So I'll tell you the way it is today. Don't know how it'll be tomorrow, and it doesn't really matter how it was yesterday. But today, always-on availability groups look like this. I have a computer designated as my primary. I have some computers designated as secondaries. I have to have one, obviously, and I may have up to 8 secondaries. One of the improvements that's being touted that will probably happen is an increase in the number of secondaries. But for right today, it's 1 primary and between 1 and 8 secondaries. So up to 9 machines we're talking about here. I'm going to just keep this simple and stick with 2 secondaries because it helps. It's all we need to explain the differences because there are 2 different kinds of secondaries. So I'm going to eliminate the clutter and say we're back to just 2 secondaries. Just like every other availability solution, I need to make that database that exists on my primary available on each of my secondaries. There are various different ways that we can do that: backup, restore, an automated process. There are lots of ways we can get this done. It doesn't really matter how it happens, but at one point in time, the primary and each of the secondaries have the exact same data in their database. One of those partners may be a synchronous partner and one may be an asynchronous partner. Now I say one, what I really should say is in SQL 2016, 3 of those partners, those secondaries, might be synchronous. All the others will be asynchronous. We're limited to 3 synchronous partners. And the best way I can explain synchronous versus asynchronous is to say this: a synchronous partner behaves just like partner safety does in mirroring. With the transaction log, the secondary is always as up to date as the primary, etc. And an asynchronous partner is just like running with no safety. And that's the best way to think of a synchronous versus an asynchronous partner. So a synchronous partner will always be 100% transactionally consistent, and asynchronous partner will not. Again, it'll probably be pretty close. I don't know what's the number, make it up 99%, whatever. It'll be close, but it won't be 100% transactionally consistent. And again, you will have to make up your mind what that's worth to you. But you can have up to 3 secondaries, which are synchronous partners. In addition to that, we have something that looks very much like the resource group and very much like the witness server, but we call it a listener. And what makes this unique is that it is a process that is running on all of, or I should say, on each of the members. It's running on the primary and it's running on each of the secondaries. And it includes, among other things, once again, the instance name and the IP address. So just like before, when my user up here connects to this server, they're technically not connecting to a server, they're connecting to my listener. And my listener does, guess what? It listens. It listens to these incoming requests and sends them to an appropriate computer. The primary computer is read-write capability. You can write to the primary. My secondaries, regardless of whether they're synchronous or not, are read-only. You cannot read or you cannot write to a secondary. You can only write to a primary. So the listener takes a look at the incoming transaction and determines whether it is going to read only or if it's going to do writing, and then it sends it to the appropriate computer. At some point, my primary is going to die, because that's kind of why we set up availability groups. So it dies, something goes wrong. Doesn't matter what it is. Something dies, and the listener on my secondaries no longer hear a response from the listener on the primary. At that point, what was the secondary becomes a primary. Now, which one becomes primary? The only machine that can become primary is a synchronous partner. It will not fail over, so to speak, to an asynchronous partner. Why? Because the asynchronous partner's data is out of date, whereas the synchronous partner is not. It's completely up to date. So it will fail over. Now, if I have more than one synchronous partner, it has to decide which one to fail over to. And that can be decided either of two ways. One, you can, and this is what I think you should do, is in advance make that decision. So you say, if the primary dies, this is the machine that will become primary. And you can make that decision and set a priority list. If you do not do that, it will go through a process called quorum that's very similar to the way a failover cluster works, and it will make a choice of my whatever 2 or 3 different synchronous partners. It will choose which one to go for. Some things might be kind of ringing some bells in your back of your brain here a little bit, and you might be starting to say, wait a minute, these always-on availability groups work a lot like a failover cluster. Well, guess what? The little surprise behind all this is each of my computers, my primary and each of my secondaries, has Windows Failover Clustering installed on it. And they are members of a Windows cluster. But that's where it stops. All administration, all activity, all control for failovers, all that kind of stuff is handled by SQL Server. So that, and the whole point here is to avoid having that one common shared disk. Each of my members has its own set of disks. Now, are those locally attached DASD drives or are they SAN drives? I don't care. It can be whatever you want, but they're not the same drive is the point. And it allows me to have a situation where my data files and my log files are not on the same drive. It's just, primary. Shouldn't say primary, that's a bad choice of words. It's significant. So in the event of a failure of my primary, one of my synchronous partners becomes primary, all the others remain secondary. Of course, as soon as this one becomes primary, it becomes read-write. And now all of my transactions that were writing to what was my primary that now failed can now continue their write operations to the primary, what has become the primary. Now, one of the things that I'm not getting into here, just for sake of time, is there's the idea of an application intent being read-only. I'm sorry, we're already running out of time quickly here, but we don't have time to get into it. But if you're interested in that and you want more details, you know, come take a class from us or get into the Expert Connect section and look at it. We'll be glad to chat through it. It's just a timing issue right now. Okay, so conclusions. I am going to leave log shipping out of this discussion because I just don't think it's a realistic high availability option for most cases. So of the 4 remaining, replication, failover clustering, mirroring, and availability groups, let's talk about these. First of all, let's take replication. What does it protect? It's pretty interesting because it protects the availability of the instance and it protects the availability of the data. Pretty good. It's really excellent at scaling. It's almost unheard of how good it is at scaling. I can scale up in a matter of minutes once I've installed SQL Server on the computer. Scaling is almost instant. I can scale to virtual machines, so I could have some of my machines be physical and some be virtual. I could have them all be virtual. I could do whatever I want there. Scalability is outstanding, and availability is really, really high. What it's not particularly good at is, first of all, geographic dispersion. The replication process is prone to failure as it gets any kind of lag. So if I'm trying to put some of those machines across the continent from me, may not be a great solution. It's also not particularly good at handling downtime because I've got a network load balancer becomes my single point of failure. Now I can certainly buy two network load balancers and daisy chain them together, and they kind of, you know, back each other up. But even so, it has that weakness. But all in all, if you need something that can be scaled up and scaled down quickly and does a good job of protection, it's great. What it's also, well, the other negative to it is it's a little tough to get set up. It traditionally takes playing with. Once it's up and running, it works really well. Okay, failover cluster. What does it protect? It protects the availability of your instance, and that's all it protects. It does not protect your data at all. And so if you were to ask any DBA, if I were to ask any of you, what would you rather protect, your server instance or your database? Your data. If any of you goes for the instance option, then you should go home and sit in a corner and think about what you've done wrong. Okay, that's bad attitude. I don't care if you can see the data nearly as much as I care if the data is intact. So failover clustering just doesn't protect my data. And so when I ask what is it good for, in SQL Server, not a heck of a lot. Now, don't get me wrong, failover clustering is great for some things. But for SQL Server, I don't think it's much of a solution. And what it's bad at is what we've already talked about. Mirroring. It protects your data, and it kind of protects your instance availability, not real well, but it mostly is there to protect your data so you can have a warm standby. If your primary machine, your original machine goes down, you can be up and running with your mirror pretty quickly. You're going to lose some stuff, but not a lot. What it's really good for is inexpensive high availability. You've got 2 computers. They don't need to be any particular computers, though they should have similar performance characteristics, but you don't have to go crazy on that. And you don't have to invest a lot of money because that machine that is the mirror can be perfectly running database operations for other databases. So I've got the XYZ database that I'm mirroring to this machine. Well, it can have the ABC database running just like a normal database, no problem. So it's not like I'm wasting my hardware. So it's a great solution for protecting my data and for being inexpensive. What it's bad at is geography. If you're trying to geo-cluster, if you're trying to move these things separately from each other, not good. Don't do mirroring. You should also know, by the way, that mirroring is deprecated in SQL Server. That's a new term to you. What it means is it's going away. They announced that in SQL 2012. Was it 2012? They announced in 2012 that mirroring will go away. The outcry amongst the user community has been so great that Microsoft has reconsidered. No, they haven't changed their mind. Microsoft would never admit. It's like a politician admitting they're wrong. It ain't going to happen. But here's what they did. They said, no, database mirroring is deprecated. However, we're introducing in SQL 2017 a brand new feature called basic availability groups. If you look very carefully, they're exactly the same as mirroring. So in other words, what they've done is they've given us the ability to go from mirroring to basic availability groups with no change other than the name. So don't let the fact that mirroring is deprecated worry you. Availability groups. It protects the data. It protects the availability of the instance. And it also does one hidden thing that I think makes it the greatest solution. These, going back to this slide, these, before it failed over here, each of my secondaries is a read-only operation. But I should have put this into the slide, but I'll show you how bad I am at freehanding things with the mouse. As an example, it's read-only, but hey, reporting services only needs read-only data. I could run my reporting services off of there. I could run my backups off of here. And if I maybe off of this one or maybe a third one, I can do my consistency checks off of this copy. And they have no impact on my primary because they're just reading data. This is dream time for me. The ability to run DBCC CheckDB on databases that I didn't used to have time to run it on, meaning I would start it when I went home at night and the next morning it was still running. Well, now I don't care. I've got it running off of an asynchronous, or actually probably a synchronous copy of this database. And I don't care how long it takes. Nobody else is using that one. And all that cost me was the price of a piece of hardware and some licensing. So what is failover cluster, or what is availability group good for? Everything. What is it bad at? Not much, to be honest with you. It handles geography well. It handles failure well. The only thing that I would ask of availability groups, and I suspect it's just a matter of time, is I would like to have more synchronous partners, and I'd like to have more partners in general. So, how do you choose? How do you make up your mind what solution you ought to have? First of all, and everybody gets these backwards. They start by saying, I'm going to start with this solution. Why? Well, because don't do that. Start with these decisions first. What do you want to protect? Maybe all you want to protect is the instance. Great, then use failover clustering. But decide first thing what you want to protect. Don't think about how available it is. Don't think about how many nines you want to have, anything like that. Just decide what do you want to protect, and then how much are you willing to spend to make that protected? Because it's going to have a price tag. And some people I've heard say, well, you can't put price on data. Well, sure you can. You can put a price on anything. Just tell me how much your data is worth. Is it worth $1? Well, of course it is. Is it worth $5 million? Oh, I don't know about that. Well, come up with a number. Decide how much money you're willing to spend to protect that data and or that instance. Then please do yourself a favor and determine how you're going to measure availability. What does it mean? And how are you going to measure it? Once you've got those down, then which one of those options is possible becomes easier. But everybody wants to start off with the what availability first and then work back from there. It doesn't work that way. You end up making poor decisions that way. So decide what you want to protect, decide how much money you're willing to throw at it, and not just how much money, how much time, how much of your people's time you're willing to make them spend. Then decide how you're going to measure that. Once you got that done, usually I find one of these solutions is going to stand out above the other. Now, one of the things we didn't talk about that I'm just going to throw out here is don't forget to think about cloud-based computing. Cloud-based computing, whether you use, Amazon Web Services or Azure or Google or VMware or whoever you use, IBM, I don't care who you use, they will very likely be able to create a higher availability than you will. Not necessarily, but it would be unlikely for your average organization to be able to match. I know that Microsoft's Azure has a 99.95 availability rating. It's going to be tough to compete with that on your own. Not impossible, but if you can beat it, you can't do it as cheaply. To go back to my first story, when I instituted high availability, they decided they wanted to go with 5 nines, 99.999% downtime. There was no maintenance window available. We had to plan around that. And we ended up investing $5 million the first time, just as a one-time investment. And I was a little nervous when I went back to them with that, and I told them, and they said, okay. Their way of thinking, it makes perfect sense when you think about it, was we're earning $2.8 billion a month. 5 million is chump change. Go right ahead and spend it. In fact, I kind of got the impression I should ask for 10, but whatever. And then it costs more per year to do that. It's not a one-time investment only. You got to keep going with it. So think about cloud-based data. First of all, every report I've read and everything I see convinces me it's cheaper to pay somebody else to host your data. It just is. By the time you think about racking and cooling and rent on the property and the people and the backups and all that kind of stuff, paying for your own software licenses, paying for your own hardware, amortizing all of that, the cloud-based computing will be cheaper. And I promise you that unless you're very exceptional, they will gain you a higher availability rate than you'll be able to come up with no matter which of these solutions you think of. So that's all I've got for you. I got finished with 1 minute to spare, maybe almost 2 minutes. So if there are questions, I'd love to answer them. If there are questions you don't want to ask now or we don't get time to answer, we will, Tim will forward those to me and I will reply and we'll get those out there. But I really want to stress to you the expertconnect.quickstart.com. That's the premier way to get answers to your questions. So Tim, lay it on me. What you got?
Very good. We did have a couple of questions come through. One regarding high availability options. Let's see, which of these high availability options are ideal for disaster recovery? What would you recommend for to subject matter experts in the IT industry?
So the first part of your question, which one's ideal for disaster recovery? Cloud-based, really, is the answer. Others are good for it. So for instance, mirroring, I can disperse these machines to different data centers. I would say probably failover clustering is not great for that, but it's not much worse than it would be normally. And mirroring is probably not a good option.
And apologize, I did say subject matter experts. Should have been small, medium enterprise.
Oh, okay. Yeah, I would say, I was going to say, I don't know about the SMEs, but I think that probably if disaster recovery is my question, I'm going with cloud-based solutions every time. I really am, because I can just at the click of a button say, let's move this over to Peru, or let's move this to Canada, or let's move it to the East Coast or the West Coast or Europe or wherever. And it just happens. And so disaster recovery is way, way better in a cloud-based solution.
And definitely cost effective.
Yeah, and definitely cost effective. Yeah, absolutely.
Yep. Had another question a little bit earlier. Let's see, can you have two synchronous computers?
If this is referring to in an always on availability group, yes, you can have two. Even in SQL 2017, you can have three. But yes, you can have two synchronous.
Okay, perfect. And one last one. I'm not sure if you're going to know this one, but why did they call it always on failover clustering when there is no difference?
Well,
yeah.
I have my smart aleck answer to that, and I have my the smart aleck answer is any question that begins with the word why and involves Microsoft, the answer probably has something to do with drugs. I don't know, but I would guess that probably it's a marketing decision is all, because there's no difference really. And I think that marketing, I think they wanted to tie the availability solutions into this always on brand. And I'm guessing that that's why, but it's purely a marketing decision.
Yeah, because it sounds good. Yeah.
It does sound, always on sounds great. I want something that's always on. Except my dog, I'd like my dog to be off once in a while.
Yeah, definitely. Those were the questions we had right now. I think we're about out of time, if I'm looking at the clock right.
All right. Well, thank you all very much for your time and your patience. I know I went long, so I'm going to turn it over to Tim, and I'm going to shut up.
All right. Thanks again, Jeff. And thank you, everyone. Feel free to reach out to me at tim.christy, and I'll leave that in the comments or the chat section as well, but it's tim.christy@quickstart.com. If you have any feedback, questions, or suggestions, I'd love to hear back from you. And thank you again for joining the webinar, and have an outstanding day. Thank you.